The load cell is made from a block of 3/8 inch thick 6061 aluminum, 2.5 inches in length and 2 inches in width. The CNC router I'm machining it on was made to cut wood and plastic. It really has to take very shallow cuts in aluminum, so it takes quite a while. In machining the load cell there are two sections, the center block area that will hold a small ball bearing and the two flex arm areas. I want the flex arms to be about 0.05 inches thick with a length of 0.7 inches and a width of 0.75 inches. I'm centering the flex arms in both the height and width, so the flex arm area is machined down to about 0.025 inches above the center line. Then cutting clearance slots along the side to get the width I want. That will give me just enough space to glue 2 strain gauges on each of the flex arms. Now to turn it over and cut away the backside area of the flex arms. Just need to keep everything lined up and even. As the arms are getting thin, I need to make sure the center block is supported, so I get as even a thickness as possible. Of course, it would have been better to wait to cut the clearance slots till last. Well, that looks pretty good. Now just need to drill a bottom clearance hole for the shaft. Now to make a bearing retainer plate to hold the bearing in place. Just going to glue an 1/8 inch thick piece of an aluminum to the block. Just a little CA glue works great. After it's all drilled up, just a little tap with a hammer will separate them. Then put a little marking die on and mark the screw locations. Drilling 2 through holes to tap for a couple of 3mm screws. then drilling clearance holes only through the bearing retainer plate. Just a quick hand tap for the screw threads. And then to mount the bearing and bearing retainer plate. Probably shouldn't, but I'm going to use the bearing as a drill guide for the center hole in the bearing retainer plate. This hole needs to be pretty well centered. The hole will be enlarged so the shaft lock collar can mount right up to the bearing's inner race. Marking up for drilling the load cell mounting holes, making them well oversized so I have some wiggle room with the alignment. And that should do it with the machining unless I have to come back and make the flex arms thinner. I want to mark the center line that I'm going to mount the strain gauges along, a mark that won't wipe off with all the cleaning that has to be done. I'm using some strain gauges that I ordered from Amazon. They were about the cheapest thing I could find. The part number listed is BF350-3AA, and there is not much information on them. Going to use Kapton tape to hold the strain gauges in place for gluing. The tape is not very sticky and CA glue doesn't seem to bond to it, so that's just what I'm looking for. Going to position the strain gauge on the tape and press it in place with just a little bit of pressure. The nice thing about the tape not being very sticky is that it makes it easy to position. Once in position, just going to press the lower part of the tape to the aluminum. I'm using the tape as a hinge to hold the strain gauge in place to put the glue down. Really overdoing the amount of glue here, but I'm pressing the strain gauge down in a kind of rolling motion to squeeze the glue out, then holding it in place with a rubber pad. After about 30 minutes, can remove the Kapton tape. Basically the same procedure for the next three. I did get better control of the amount of glue used and covered my rubber pad with Kapton tape so it didn't get glued to the aluminum. The terminal boards are just epoxied down. The epoxy seems to stay a little flexible, so I don't think it will affect the flex arms. This is the second load cell. On the first one, I didn't use the terminal board's only flex arms. I used Kapton tape with short strips of 0.08 inch wide copper tape on top of it to make the tie terminals. But I don't think it will stay in place very well, so I'm trying the epoxy terminals on this one. The terminal boards are just a PC board I had made and then cut the sections out of it. The strain gauges are going to be wired up as wheatstone bridge. I used enameled wire to connect the strain gauges to the terminal blocks. I think it's 32 gauge, I didn't measure it, and the label is missing from the spool. I don't want to apply too much heat to the strain gauges, as heat is not a friend of CA glue. And I used 30 gauge Kynar insulated wire to connect the flex arm terminal block to the main terminal block.
Log cabin lovers deserve the best. Visit eloghomes.com to see hundreds of spectacular log cabins. Register now at eloghomes.com and qualify for an additional 25% off and free handcrafted options.
How do you gauge the greatness of an SUV? Is it to carry cargo or to carry on a legacy? Its show of strength or its sign of intelligence? In crossing harsh terrain or breaking new ground? This is the Mercedes-Benz SUV family. Greatness comes in many forms. Visit your local Mercedes-Benz dealer for exceptional lease and financing.
Now time to do a little testing and see if the aluminum bends like I think it will.